Good evening, everyone. This is Mrs. Taylor. We are live again on Monday night for some Monday Night Math. Welcome, welcome one, welcome all. So tonight we are going to be doing a couple of problems that I'm going to be doing a couple of problems that I received through from this past week. And I just want to share that with you. I won't be on here very, very long. I don't have a lot of problems to do tonight. But what I do have, I will do. So let's go ahead and get started. So if you have a math problem that you would like for me to do for you, you can text me anytime at 407-801-9255. So if you have something later this week you want me to do, just let me know. Send me a text message, and usually I get back with you pretty soon, within a couple of hours, sometimes within the same hour. So if you have a math problem you want me to do, just let me know. Other than that, here's the first one for tonight. So this was sent to me from a student. It says Jim can fill a pool carrying buckets of water in 30 minutes. Sue can do the same job in 45 minutes. Tony can do the same job in 1.5 hours. How quickly can all three fill the pool together? So this question is a little bit difficult. You're like, well, how do you go about solving this? Well, here's how you can think of it. We have Jim. Let's see here. Jim can do the job in 30 minutes. Okay? So that means that he would fill 1/30 of the pool. Let me change the size. 1/30 of the pool per minute. Okay? So I'm going to put T for time. And time is going to be time T would be in minutes. Okay, so he could fill the pool in 1/30 of the time. And then you have Sue. Sue can do the job in 45 minutes. Okay, so she could fill 1/45 of the pool in per minute. Okay, so we're going to put times T. Then you have Tony. Tony can do the job in 1.5 hours. Or he could do it in 90 minutes. So we'll convert his to minutes as well. And we could say he does 1/90 of the pool per minute. Okay? So we can add all this together. We can add up what Jim could do, plus what Sue can do, plus what Tony can do. So these are all of their contributions to the job to get it done, to do that one job when we set this equal to 1. So at this point, we're just trying to find the amount of time, which is T. So in order to solve this type of question here, you need to find a common denominator. And in this case, we have 30, 45, and 90. I know that I can multiply each one of these fractions by 90, and I will get whole numbers. Or I would clear the fraction or get rid of the fraction. So if I do 90 times 1/30, I'll get 3T. If I do 90 times 1/45, I'll get 2T. And if I do 90 times 1/90, I'll get just T or 1T. And then I also have to multiply 90 on this side, and I'll get 90 as well. So now you add them together, you get 6T is equal to 90. Divide both sides by 6. And T is equal to, hold on, let me get my calculator. We have 90 divided by 6, and we get 15 minutes. So altogether, the 3 can fill the pool in 15 minutes. All right, let's go to another problem. So this problem was also sent to me by the same student. This one says Manuel starts with $30. He earns $8 per hour plus an additional bonus of $12 per each day. He spends $8 for lunch. If he has $94 at the end of the day, how many hours did he work? So I had to assume that he was, well, let's do it like this. So let's talk about what he has for today. Hold on for a second. Hold on. Let me see, where did I do this problem? Okay. What did I do? Okay, so I started with $30. So we start with $30. So it says he earns $30 and he earns $8 per hour plus an additional 12 hours each day. He spends $8 for lunch. If he has $94 at the end of the day, how many hours did he work? So we start out, this is the income. We'll treat it like income even though it's not. Well, it is. He has $30 and then he's also earning $8 per hour plus $12 each day. All right, so that's what we have. Then he what was the next thing that I did here? Okay, then we add this together. This is the amount of money that he basically has. So it's 8 hours plus, what is that, 42? Okay, so that's how much he has. And so we know that's the amount of money that he has, and he earns $12 each day. Now we want to take away $8. If we take away $8, and then by the end of the day he has $94, let's see what he has going on. So what is 42 minus 8? Let's see here. This is $34. So right here, this equals 34. So we have 8 hours plus 34 equals 94. And we subtract 34 from both sides. And we get 8 is, oh, hold on. 8H, which was hours, is equal to 60 or $60. And then we divide both by 8 here. And so now we have, where's my calculator? We have 60 divided by 8. And so we have that he worked, the number of hours that he worked was 7.5. And that's what we have for Mr. Manuel. So as to go back over it, he starts out with $30. He's making $8 per hour, and plus he gets $12 each day. Okay, so then he spends $8 on lunch. Well, for the first two sentences, we combined them together. So that's the first two sentences right here. We combined them together because that's like how much money he's bringing in or how much income he currently has or will have. And then we take away how much he spent on lunch, which is $8, and we know that he has $94 left over. So that is how we came up with this equation here. This one right here. All right, so we have that manual work 7.5 hours for that day. Let's go to another question. Let's see here. So it says Cosmo is taking a trip. Oh, and this is sent to me by the same student. So Cosmo is taking a trip from his house to the airport. If he drives 60 miles per hour, he will arrive 1 hour early. If he drives 30 miles per hour, he will arrive 1 hour late. What is the distance from his house to the airport? So we got two scenarios here. For the first scenario, so we'll say number one, the first scenario, he's driving to the airport at 60 miles per hour, but when he does it, his time is 1 hour early. So before we get started with setting up the problem, everything is based off of this one basic formula. Distance equals rate times time. Okay? So what I do know is that both of the distances for both scenarios will be the same because he's going from his house to the airport. Okay? So for the first scenario, and we'll have t is equal to time, we'll say that his rate, which is 60 miles per hour, and then we're going to multiply that by the time. Well, the time is, whatever the time is, we're going to subtract 1 hour because he's driving fast and they say he gets there an hour early. For the second scenario, so we'll say, let me put it in a different location. Hold on. Let's put scenario 2 here. For this scenario, he's driving 30 miles per hour, but his time, we're going to add an hour because it says he will arrive an hour late. So we're going to add 1 hour to that. So because both of these equations are set to D, we can set them equal to each other, and we can solve for time. So we'll say 60. And this would be t minus 1 is equal to 30, and this is t plus 1. So I'm going to distribute, and I'm going to call it 60t minus 60 is equal to 30t plus 30. I'm going to subtract 30t from both sides. And I get 30t minus 60 is equal to 30. I'm going to add 60 to both sides. Get my zero pair, and I have 30t is equal to 90. So t is going to be equal to, hold on, let me not skip steps. Let's divide both sides by 30. Make sure I show my work. So t is equal to 3 hours, okay? So it basically takes 3 hours to get from his house to the airport. So, but using each one of the scenarios, but driving at 60 miles per hour, let's see the distance, okay? So we'll say 60 times 3 minus 1, and we get 60 times 2, which is 120 miles. Okay? We need to get the same answer over here to make sure that we did it correctly. So we say 30 times 3 hours plus 1, and you get 30 times 4, which is also 120. So, what is the distance from his house to the airport? We're going to say B, 120 miles. Okay, let's keep going. Okay, so this question came from a 6th grade student. This person wanted me to do question 13 for them. So it says complete each sentence. It says 4 students is blank percent of 20 students. So I'm going to write it out because I like to translate my sentences like this. So 4 students is blank percent of 20 students. So here's how I would translate this sentence. I would take four students, and I would put 4. The word is means equal. When you're working with the percent is always out of 100. So I put P over 100. The word of means multiplication. And then we have 20 students, and we put 20. Okay, this is just one way of doing it. I know another way to do part over whole is equal to the percent, P over 100. So here's just one way of doing it. So I can, on this side of the equation, I can rewrite this as a fraction. So change my whole number of 20 to a fraction. And so I can rewrite this as 4 is equal to 20 over 100, and I put P here. And so what I could do is multiply both sides by the reciprocal. So this could be 100 over 20 times 100 over 20. Okay, I could change this whole number 4 to a 1 as well. So I get 400 over 20 is equal to P. So 20 is here, and then you have 400, and that's going to be 240. Subtract, bring the 0 down, 0. So the answer here would be P is equal to 20, or 20%. So 4 students is going to be 20% of 20 students. Okie doke. Let's keep going. Alright, I got this message from a colleague of mine, and they asked me to do it for one of their friends. So it says simplify. Express your answer as a single term without a denominator. That was the part that was hanging them up. Express this without a denominator. So for this question here, you have y equals negative 80 as the exponent times y equals 0. Now here's the rule. This right here, any base that's raised to the 0 power is equal to 1. So instead of having y times y0, this is going to be y negative 80 times 1. Okay, and we already know that anything times 1 is going to be itself. So the answer to this question was just y equals negative 80. And that is what they were looking for. And they say give your answer without a denominator. So yeah. Now if they wanted a denominator, we could have rewritten it as 1 over y, and then it would have been a positive 80. But this is not what they wanted. They wanted without. So this is without your denominator. And of course, this is with your denominator. All right, let's keep going. Okay, this right here is just a regular 8th grade standard. It says a cylinder with a height of 6.5 inches and a diameter of 5 inches is shown. What is the volume of the cylinder in cubic inches? Use 3.14 for pi. Now, in order to find the volume of a cylinder, it's going to be V is equal to the area of the base times the height. So the area of the base, first off, we got to figure out, well, what shape is the base? So capital B stands for the area of the base. In this case, my base is a circle. To find the area of a circle, you have to say pi r squared. So let's look for the area of the base first. So this is going to be A is equal to 3.14. They say the radius is 5, but the diameter is 5. So the diameter is 5. The radius is half of the diameter. So the radius is going to be 1/2 times 5, or 2.5. So this is going to be 2.5 squared. So let me get my calculator because I'm not trying to do that math. 2.5 times 2.5 times 3.14. And so the area of the base is 19.625. Okay? So this would be inches squared. So now to find the volume, you take your 19.625, which is the area of the base, times the height of the cylinder, which is 6.5, and you multiply that. So 19.625 times 6.5, the volume of this cylinder is 127. Did they say what it says? What is the volume in cubic? Yeah, they didn't tell you what to round it to, so we'll round it to the nearest hundred. So we'll say 56, and this would be cubic inches, or you could write it as 127.56, and you could say inches and the exponent of 3. All right. There you have it. Okay, let's do one more. It's almost been 30 minutes already. Yes, Talia, girl. Sometimes you just got to pull out your calculator because that's what we do in the real world anyway. Okay, so this is my last question. It says the diameter of a sphere is 4 inches. What is the volume of the sphere in cubic inches? So in order to find the the volume of the sphere, you have to use the formula V equals 4/3 pi r cubed. And of course the R stands for radius. And again, so we say the diameter is 4. The radius is going to be 1/2 your diameter, or 1/2 times 4, which is going to be 2 inches. So to calculate this volume, you would say V is equal to 4/3 times 3.14 times 2 cubed. So again, let's pull out our calculator because guess what? We're not trying to do this math by hand. Not today. Not Monday. I'm not having it. So let's go in order. So 2 cubed is 8. So we got 4/3, 3.14, and we got the number 8. Okay, let's multiply across. So 4 times 3.14 times 8, and then divide that by 3. And so our volume, and it does not tell us what to round to. So I'm just going to pick to the nearest, I'm going to go to the nearest thousandths because of what I see. So this is going to be 33.49, and the 3 is repeating. So we're going to put a nice little line over the 3 because that is a repeating number. And this is going to be cubic inches as well. All right, guys. That's it. That's all. Yes, Talia, honey. Work smarter and not harder. You right about that. So So I have enjoyed my time with you. I'm going to call it an evening. Just like other people have been sending me questions throughout the week, anyone is more than welcome to text me their math questions. I usually get back with you the same day. And if you need help, just text me 407-801-9255. I am here. I am here to help you because I know it's a lot of folks out there that need help with some math. So I will see you next Monday. Ta ta for now. Bye bye.